doing my SFP on the comparison of synthetic and organic sorbents. To start off with a little bit about me, my name is Addyson Hunsicker, and I'm currently a senior at Tunstall High School. And next year I hope to attend a 4-year university to pursue a degree in nuclear engineering. I chose this study because of my personal love of the ocean and how much time I've spent there in my life. And the increase in the frequency of oil spills caused by the age of technology in the past 30 years has caused harm to the organisms which I love and the environment in which I spend so much time. When I started my literature review, I first had to answer the question, what is a sorbent? A sorbent is a hydrophobic material used to remove oil particles from water and leave only the water in the organisms left behind. There are 3 main types: organic, non-organic, and synthetic. Organic sorbents are completely made from the environment and do not contain manufactured byproducts. Synthetic are the complete opposite, and they are fully manufactured, containing chemical and plastic-based products. And non-organic are the ones in between. So they normally have organic origins, like being moss or soil-based, but then contain chemical treatments to create a more hydrophobic material. For my study, I focused on 2 main types of synthetic and organic. And when you're testing the conditions of a sorbent, you're testing 4 main quantities: the expense, the sustainability, the absorbency, and the harm done to the environment in which it is used. Synthetic are very expensive and unsustainable due to the way they are made. They come from plastics and chemical elements that cannot be easily obtained and will one day run out, which makes them very unsustainable. However, they do have the best absorbency because they are made specifically for this purpose and contain no other uses. However, this does create a very harmful chemical component that will leave residue in the waterways. Organic, on the other hand, are very cheap and sustainable because they are moss or soil-based products and don't contain any manufacturing, leaving them out of the factories and out of labs across our world. However, their absorbency can be very testable, from anywhere from a 3:1 to a 6:1 ratio. They do not contain harm because they are organic, and they do not contain chemicals. For my research, I answered the question, is there a preferred type of sorbent between organic and synthetic for the cleanup of oil spills? To start, I made my hypotheses. My research hypothesis states that if peat moss sorbent is used, then there will be less reduction in oil properties than if polypropylene pads are used. My null states that if peat moss is used, then there will be no statistical difference than if polypropylene pads are used. When conducting my test, I had to point out my variables. My independent variable is the type of sorbent in which I have used. In the top photo, you can see polypropylene pads, which are my personal synthetic sorbent, and in the bottom photo, you can see 50 milligrams of peat moss, which is my personal organic sorbent. My dependent was the effectiveness under 2 quantitative quantities, which is harm done to the environment in which they're used, and the absorbency. My control is oil and plain water, set up the exact same way for all 6 tanks in which I used. And my constants were the type of water, which is Danville City water, the type of oil, which is 20 WW motor oil, and the mixing speed of 60 rotations per minute. For my methodology, I first had to prepare my tanks, in which I filled 6 tanks with 5 gallons of water each. I then measured 10 milliliters of oil and poured this into the tanks and waited 10 minutes for a process called dispersion to occur. This process, as you can see in the top photo, slightly mixes the oil and water particles and makes it a much harder substance to remove. I then conducted my control testing, in which I took 10 water samples, 5 from each tank, and I logged their pH using the dipping method with pH strips, and their oil residue using a photo scale from Tempora et al. I then conducted my organic testing, in which I placed 30 grams of peat moss into mesh bags to create a barrier between them and the water, because it would get lost in the water if you do not use this barrier. I mixed the bags into the tank for 10 minutes using a hand mixer, and then I removed the bags and masked them for their final weight after waiting 10 seconds with the dripping method to remove that excess water that would have been held behind. I then took 10 more water samples from the 2 tanks, 5 from each. I once again logged their pH and residue, as well as this time using their sorbent residue with also a scale photo from Tempora et al. And their temperature to remain that this stayed constant between all of my tests. I then did my synthetic testing, in which I placed 30 grams of polypropylene pads, which is once again 3 pads. I mixed the pads into the tanks for 10 minutes, and I removed the pads and masked them once again using the 10-second test. I took 10 water samples from the 2 tanks and logged their pH, residue, sorbent, and temperature. I logged my raw data and conducted a statistical analysis. For my statistical analysis, I chose to do 4 one-way ANOVAs for each of the quantitative variables I concluded. And at the significance level of 0.05, the null hypothesis was rejected with a p-value of less than 1/1000 for all dependent variables. For my first condition I tested was the harm done to the environment in which it was used. I first logged my pH because this can be a major change when you're using sorbents. The Danville City water I found and used had an average pH of a 7.5 to a 7.10. For my control, it went up to a basic level of an 8.1 with just oil in the water, and organic brought it back down to that average level of a 7.05. Synthetic brought it all the way down to an acidic level, which is very average for synthetic sorbents. However, this can cause a huge detriment to the organisms which live in the water and can change the way their polymers and monomers form and how they consume the organisms and the nutrients from the water they use. For my second test under the harm condition, I used a photo scaling of remaining sorbent in the water, and as you can see, there was a large difference found. Due to the peat moss and the way it is ground, it does leave behind a lot of residue and pieces behind, changing the color of the water to almost completely black, which can change the way the chlorophyll of the organisms which live in the bottom of the ocean not to be able to retain as much light. So synthetic only had a 0.7 average of this residue, and this was caused by one sample I took with 3 pieces of plastic sorbent left behind, which could have been user error or shipping error because when we did get our package from the company, it was damaged. For the next quantity I tested, it was the absorbency. With an oil residue scale from Tempora et al., 5 was the basic level with full coverage of oil residue. Organic brought it down to a 2.9, which is about a 3-to-1 ratio of absorbency of gallons of water to oil, and then synthetic brought it to a 7.1, 1.7, which is less than a 2-to-1, which is very good for sorbents. This conducted that statistically synthetic did absorb more oil and left less residue behind. For my weight change of my sorbents, I concluded that synthetic absorbed a lot more oil, almost 10 grams more on every test that I conducted. However, those large error bars, as you can see in my photo, go against most of the research in which I concluded that said that synthetic was always the same and very constant, which is why you should use it. However, I found that my organic was much more consistent in the amount it absorbed, which can cause a very questionable outcome because if you use more synthetic, you're obviously going to pay more, and that can be very inconclusive in your research and what you use in the actual ocean and lakes. There was a significant difference in all my results, concluding that one sorbent conducted better in each quantitative variable in which I conducted. Synthetic has a higher absorbency under the condition of oil residue and weight change. However, they both change system conditions in their own manner that can both be detrimental to the waterways. Mine does align with a lot of existing research. However, existing research does not go in depth about their statistical testing and normally just gives it normal, just says synthetic is better or organic is better, not giving any quantitative variables. Synthetic was found to be more effective with 3 out of 4 tests I ran, concluding that it affects the water in a more manageable way. However, further research is needed with these things that do not align in my research. I had 3 major limitations when conducting my study. The type of oil I used was not crude oil, which is normally used in the oceans and waterways and what is spilled off of these large tanker ships. I also had a much smaller scale because you cannot pour oil into lakes and waterways. So I'd use small 5-gallon tanks, which were accessible to me, but this doesn't make applicable to the ocean and how most tests are ran. I can also not test exactly with the photo scales from Tempora et al. I had to use because the resources contain a lot of chemical testing that would not be allotted to me as a 17-year-old. There does need to be more testing because there's over 100 different sorbents in the world, and all of these can contain different goods and bads and harms to the environment. This also needs to be done on a large scale, such as an ocean, after a spill has already occurred with proper experimental design. Because we still use these things in our oceans, however, without the proper experimental design and the research done, you cannot use those results as sufficient evidence. Over this process I started late in 11th grade, I found that I loved the process of research and I loved starting from the beginning and going all the way to the end and finding my own passions. And this is what I would like to do, and I would like to study the research field of nuclear engineering. This also gives me new perspectives on the things I use in my world, because everything can say it's perfect, like these sorbents that we use in our oceans for years and years. However, they can cause huge detriments in the organisms and change the way these environments work for years. I would like to thank my advisors, Ms. Long for helping me with the research process, Mrs. Fain for approving my methodology, and Mr. Harrell for setting up my statistical analysis. I'd also like to thank Piedmont Governor School for this opportunity. And at this time, are there any questions?
I think I heard you say that the synthetic lowered the pH more than the organic. So, and that was a detriment to organisms in the water, is that correct? Am I understanding correctly?
Dr. Mark Jones is asking if the pH change can cause a detriment in the organisms from synthetic. Synthetic does lower the pH to an acidic level, which can completely change the way the organisms live and normally kills them. So that could be very harmful to any life that's living in the water.
Is there something maybe you could add? Is there a technique that you could add something back to the water to increase the pH?
Dr. Mark Jones is asking if there is something you can add back. In my research, I did not come across anything. That is why organic is being researched more heavily at this point. However, those non-organic in-betweens can definitely even out the pH.
So when you discussed your methodology, you said you put 30 grams of peat moss in bags and use that to compare to the synthetic sorbents. How did you decide the amount of peat moss to use to have a good comparison? And how do you think that the testing would have been impacted if you used more or less peat moss in the study?
Yes, sir. Mr. Eads is asking about how I decided on my amount of peat moss and my amount of sorbent. My studies gave very detailed methodology. That is a great thing in the field of sorbents. Most studies I actually read were just methodology. They gave you no actual results. So my methodologies gave me precise, accurate measurements for how many grams of peat moss you should use for each milliliter of oil in each gallon of water, which is what I scaled mine with. And then I made them even based on the quantities given to me by the manufacturers of the sorbents.
So what do you think would have happened if you used 40 grams instead of 30 grams?
So there would have definitely been a detriment in the pH. For synthetic, it would have left behind a lot more chemicals, and it also would have peaked at its absorption at the rate that my studies gave me, and it would just have left the chemicals and would not have changed the actual absorbency of the sorbents at that point.
Okay. So no more absorbency, but more acidic?
Yes, sir.
I'm curious as to why you only tested on like fresh city water. Was there a reason that you didn't want to test your sorbents against salt water, like you would find in the ocean?
Ms. Kent is asking me about why I use city water. My study already had a very large cost due to the synthetic sorbent and the organic sorbent, and then I also paid with my own money for the oils and the bagging and stuff like that. Just that would be another expense which I could not reach at that point.
So why did you choose 10 milliliters of motor oil in comparison to your size of your aquarium that you used?
Ms. Collins is asking why I chose 10 milliliters of motor oil. In my methodology, that was also very well researched, and when you tested those things, they gave me exact quantities, and 2 milliliters for every gallon of oil would give you about a right quantity and an equal quantity that I could easily measure.
If you could do this again, what other organic materials do you think you would like to try?
Ms. Collins is asking what other organic materials I would like to try. I used a moss-based, but soil-based are very interesting to me, and the microfilaments are made so differently that it could absorb in a very different way, and I would love to research that. So a soil-based organic would be my next choice.